So let's get started with the questions on nuclear chemistry from the real JEE exam. And I've already shared the PDF of the questions with you. Hope you would have given it a good try by now. And now I'll begin with question one, which is about aluminium getting bombarded by alpha particles. Now, before I begin, I guess this is understood by all of you. Alpha rays are basically helium nuclei, which is like He plus 2 with an effective charge of 2 and mass 4. Beta ray naturally is an electron only with an effective charge minus 1 and charge 0. Effective charge minus 1 and mass 0. Naturally, a neutron is going to be represented by small n with a charge 0 and a mass plus 1. A proton is obviously going to be having a charge plus 1 and mass 1. And positron is basically a positive electron, which is the reverse of a beta ray or an electron, and will be represented as a beta plus 1 0. Are you all happy with this? I think it's understood by everyone. Alpha ray being a helium nuclei will be having 2 proton, 2 neutron. So the net charge will be 2 units and the mass will be 4 units. Beta ray would be an electron only with a charge minus 1 and no mass. Neutron will have a charge 0 and a mass plus 1. Proton, would have a charge plus 1, mass plus 1. Positron, I repeat, is going to be, the positive counterpart of an electron. So I'm writing it like a beta ray with a positive 1 charge. And naturally, the charge positive is about the reverse of an electron. Mass would be negligible. Let's get started with question one. I hope you all are there with me. I want people to respond. Please go ahead. Question one. 2011 का क्वेश्चन है. यहाँ तक कोई प्रॉब्लम नहीं मेरे को लगता है. आई थिंक ये सबको समझ में आता है. 2011 जेई का क्वेश्चन है. Alpha ray is bombarded with helium nuclei or an alpha ray. So this is how an aluminium nuclei 1327 is eventually getting converted to phosphorus, which I reckon is 1530 given in one of the processes. This is 2, I reckon. One is this one, where naturally it's going to give you silicon with an X, silicon 1430 plus X. Again, it's about bombarding it with helium. And this phosphorus is eventually giving you in another change. What people are joining the class right now? Silicon 1430 and a species which is Z. So basically, when you have to identify X, Y, and Z, hey, you go with the very basic rule of equating mass and charge. Who will tell me what is X out here?
Neutron.
Naturally, 13 plus 2, 15. 13 plus 2, 15, and 14 here would mean this is plus 1. And certainly 27 plus 4, 31. And I'll know that, 30, I'll need a plus 1 here. So X has to be a proton. X has to be a proton. Plus 1, plus 1. Similarly, 13 to 15 and 27 for 31, I'll effectively need something with a charge 0 and a mass plus 1, and I guess that's going to be a neutron. Yes or no? Z, which is about equating, this particular nuclear change. 14, this is 15 here in the charge column. So this will be plus 1. And 30 plus 1, 31. This will be plus 1. I hope I'm doing it all right. Z, नहीं. Z में ना इसको नहीं देखना है. Z में इसको नहीं देखना है. सिर्फ इसका बात कर रहे हैं. सिर्फ इसका बात कर रहे हैं. तो 15 is 14 plus 1 and 30 is plus 1 0. So that is naturally a positron. Am I being understood? Proton, neutron, and a positron. So in the real question, this is option A written. Are you all happy with this? We want to move to question 2. तो चलो हाँ ना बोलो.
Yes, sir.
So the way I usually go, I would give you a couple of seconds to take a screenshot. In case you want to see it a little later or you have a doubt, you can ask me right away. At the count of 3, I want to move to question 2. So I hope you have uh, understood this or taken a snapshot, and we'll move to question 2. Question 2 is about a positron emitted from sodium 1123. Now this is sodium 1123, which is supposed to be the positron. Now this is a positron. I hope you understand. This is a positron. And the species X which you have, if this is the atomic number and this is the mass number, the question at hand is the ratio of atomic mass and atomic number. So I believe atomic mass is the same as mass number here. I believe atomic mass is the same as mass number here. And what I want is m by a. So please go ahead. I mean, if you've got the right answer, you'll want to respond.
So
I
C
think you're
Calcutta.
all there with me. C Calcutta.
Yes, sir.
Question 3. You can stop me if you have a doubt somewhere. Sodium 23 is a more stable isotope. Find the process by which sodium 24 can undergo radioactive decay. Now this is important. देखो सोडियम सोडियम तभी होगा जब वो 11 होगा. तो ये लिखा हो चाहे नहीं लिखा हो, naturally this is less stable and the form which is more stable is 23. बच्चे लोग हाँ ना बोलो.
हाँ, sir.
Now this is something which I have discussed in the Howrah batch. Also discussed in the Full Bagan batch with a little lesser time. So I would want to give you a small briefing on this. Do you realize that between sodium 24 and sodium 23, this has a higher N by P? The one with more mass number will have more neutrons, yes or no?
Yes, sir.
Now the rule of the game is it's the N by P ratio which dictates radioactive behavior. Now if the N by P ratio is more, I repeat, this is important. N by P अगर ज़्यादा है, so you would very seriously consider a beta emission. A beta ray emission, this is how a beta ray gets emitted. A neutron gets converted to a proton. A neutron gets converted to a proton. This is how a beta ray is going to come out of a nuclei. It's a very common question and a very, very obvious fact that the beta ray, which is basically an electron which comes from the nuclei, is about a neutron becoming a proton. And don't you think in the process of a neutron becoming a proton, in this entire process, N by P ratio is lowered? Now, every time N by P is high, it will be controlled by a beta minus emission. Beta plus यहाँ पर दिया, which is a positron. So I think 3A Agra should be the right answer. I think that's the common answer as well. बच्चे लोग हाँ ना बोलो. 3A Agra should be the answer. बच्चे लोग हाँ ना बोलो. Option A है. I would want you people to respond. Please go ahead. I think my voice is loud and clear. I hope I am being understood.
Yes.
Yes, sir.
Trust me, this is when the N by P ratio is high, and this is how the N by P ratio is lower. So because in a beta emission, neutron will become proton, N by P ratio will be lower. So what is beta emission going to take care of? A high N by P. And trust me, the rest of these three would be the case when by N by P ratio is low. So when the N by P ratio is low, when the N by P ratio is low, please hear me out. Every time N by P ratio is high, you'll have a beta emission, and we'll see cases in future where if the N by P ratio is low, an alpha emission or a positron emission or a K electron capture. This is about losing an electron, it's about gaining an electron from its first orbit. Naturally, this is the reverse of electron, and alpha and beta could be taken as two antagonistic emissions. So this is how a student is supposed to remember. Please hear me out. These are the two cases where you'll have a radioactive activity. If it's high N by P, let it get controlled by a beta emission. And if it's a low N by P, either an alpha emission or a positron emission or a K electron capture would be, the remedy. We'll want to move to question 4. If you have a doubt, you're welcome. Else we'll want to move to question 4. बच्चे लोग हाँ ना बोलो.
सर एक डाउट है
Please go
सर
ahead.
वो मास नंबर में तो कोई चेंज नहीं आएगा ना बीटा एमिशन से तो फिर 24 Na11 23 Na11 कैसे बन जाएगा
मतलब यहाँ पर ये नहीं बोल रहा है, इट्स अ वेरी जेन्युइन क्वेश्चन. यहाँ पर ये नहीं बोल रहा है कि इससे ये बन रहा है, इससे ये बन रहा है, ये नहीं बोल रहा है मेरे भाई. यहाँ पर बोल रहा है कि इन दोनों आइसोटोप में ये वाला ज्यादा स्टेबल है, ये कम स्टेबल है. यहाँ पर ये नहीं बोल रहा है कि 24 इज बिकमिंग 23. प्लीज रिस्पॉन्ड टू मी. डज द क्वेश्चन रीड that you have to convert this to this? Does the
नहीं सर
question read that you have to convert this to this? It's a very common, doubt where you think that, they ask for a conversion. No, they don't ask for a conversion. It's not like, I'm expecting this to become this. What I'm only understanding is this is a more stable isomer, it's a less stable isomer. And a lesser stable isomer has a higher N by P ratio. Nowhere in the question is it talking about 24 becoming 23. So that is why I'm not going about figuring out this particular change or this particular, conversion. ऐसा convert नहीं हो रहा है. I hope I'm being understood.
यस सर
The rule of the game is अगर n by p ज्यादा है तो बीटा एमिशन करो, n by p अगर कम है अल्फा एमिशन करो या पॉजिट्रॉन एमिशन करो या k इलेक्ट्रॉन कैप्चर करो. We'll move on. Question 4. At the count of 3, please take a snapshot if you want. Question 4, Adam. Question 4.
So B Bombay.
Invoke nuclear fusion. Uranium 92 to 35. Uranium 92 to 35 is undergoing a fusion. अच्छा यहाँ पर एक न्यूट्रॉन अब्सॉर्ब भी कर रहा है. तो यहाँ पर जब एक न्यूट्रॉन अब्सॉर्ब कर रहा है तो ये मेरे को ऐड करना होगा 92 plus 0 231 plus 1 plus 235 plus 1. And the question reads xenon 54 139 बन रहा है. So this is very very routine. This is very very routine and very very common stuff. Where I would eventually want to just equate charge and mass, and if it's x number of neutrons which are being released in the process, what's the count, what is x here? ये तो naturally 54 plus 38 ही रहेगा because इससे कोई फर्क नहीं पड़ता है. The mass number and 235 plus 1 is equal to 139 plus 94 plus x is how I'll get
नहीं
x.
होगा
क्या होगा मेरे भाई? 3, which is option D, I reckon. You're all there with me? बच्चे लोग हाँ ना बोलो.
हाँ सर.
देखो क्वेश्चन 5 वैसा ही है जैसा क्वेश्चन 3 था. क्वेश्चन 5 भी वैसे ही जैसे क्वेश्चन 3 था. Question 5 में भी you want to read the language. In question 5, all it tells you is aluminium is a stable isotope with a mass number 27. So they tell you that this is stable. This is stable. And with a mass number 29, this is less stable. Now you realize the one which is less stable is a higher N by P. Any doubt here? Any doubt here?
No.
And a higher N by P will be treated by a beta emission. Beta minus लिखो. बीटा माइनस लिखो, ऐसा लिखो. ऑप्शन खाली बीटा लिखो. ई बॉम्बा. इसके बाद ना इंटीजर वैल्यू क्वेश्चन था. क्वेश्चन 9 बहुत बढ़िया क्वेश्चन है, 2015 में आया है. क्वेश्चन 9 इज अ वेरी नाइस प्रॉब्लम व्हिच हैज कम एज एन इंटीजर वैल्यू. क्वेश्चन इन 2015. You can stop me if there's a doubt anywhere. So far so good, I reckon. Question 9. You have a closed vessel with rigid walls. So let me draw the picture. You have a closed vessel with rigid walls, and what you have inside is 1 mole uranium and 1 mole of air. So you have 1 mole of U92. दो आइसोटोप होता है 235 और 238. यहाँ पे 238 दिया है, प्लस 1 mole air. Yes or no? That's the problem at hand. Now this is the change happening. U92 238 is becoming lead 82206. Now this is the most natural radioactive series. It's the most active natural radioactive series. Let me ask a more fundamental question. The question here is, if suppose the truth is X alpha and Y beta, find X and Y. Some of you would have done it before class 11. If you know about alpha and beta rays, some of you would have done it before class 11. Please tell me, what is the trick to go about finding number of alpha and beta particles coming out in a radioactive series? बच्चे लोग, I
तो
give you a
पहले
minute to solve this. Yes, please.
तो पहले मास नंबर देखेंगे.
Naturally मास नंबर देखेंगे, बिकॉज बीटा में मास नंबर चेंज नहीं होगा. मास नंबर देखो, एटॉमिक नंबर दोनों में चेंज होगा. So mass number is controlled only by alpha emission. So naturally we'll start with the difference in the mass number. I want the answer now. Do you relate to this? Do you relate to this?
Yes sir.
Now, ऐसा नहीं कि 8 अल्फा एक बार में निकल जाता है. इट कुड बी लाइक अल्फा 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 बीटा 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 अल्फा बीटा बीटा. टोटल 8 अल्फा निकलता है और फिर कुछ बीटा निकलता है जिससे इवेंचुअली लेड आता है. नाउ ये बात तो बिल्कुल क्लियर है कि अगर इसमें से 8 अल्फा तुम निकाल दोगे तो ये तो तुम्हारा मास 206 हो जाएगा. दैट्स नॉट अ प्रॉब्लम. पर 8 इंटू 2 16. जब 16 निकालोगे यू से तो ये तुम्हारा आएगा प्लैटिनम. अब मेरे को याद है, जरूरी नहीं तुमको याद रखना पड़े. 16 माइनस करोगे तो ये 78 है या 76 है, क्या है? 8 दूनी 16, 76 आएगा. 76 इज नॉट प्लैटिनम. 76 इज जो भी. ये 76 ही आएगा ना बच्चे लोग? आई होप आई एम डूइंग इट ऑल राइट। बच्चे लोग हाँ ना बोलो।
हाँ सर।
76 किसका होगा? 80 मरकरी है, 79 गोल्ड है, 78 प्लैटिनम है, आयरन कोबाल्ट निकल, रोडिनियम रोडियम पलिम्स, एंड देन ऑस्मियम इरिडियम प्लैटिनम। ये ऑस्मियम आ रहा है क्या? देख तो, मेरे को लगता है
हाँ
ऑस्मियम
सर।
ही होगा। ऑल्दो मेरे को पता होना चाहिए सबका एटॉमिक नंबर विथ आवर अंडरस्टैंडिंग ऑफ दैट ऑफ पीरियोडिक टेबल। आई होप आई एम डूइंग जस्टिस टू दिस। Osmium 76, iridium 77, platinum 78, gold 79, 80 mercury. But this is important that you understand 92 minus 8 into 16 would be 76. And from 76 to 82, you know, with every beta emission, you have the atomic number going plus 1. So this has to be 6 beta emission, yes or no?
Yes sir.
So all in all, 8 alpha and 6 beta, x is equal to 8, y is equal to 6 is something, you know, which has to be known by every science student around this thing. I hope I'm being understood. Now, beta particles are electrons only. Alpha rays are helium nuclei. So just naturally losing 8 alpha, which is the helium nuclei, and this helium nuclei will capture electrons from the atmosphere and will become helium gas. So naturally, in course of 1 mole uranium-238 becoming lead 82206, you'll have 8 helium, 8 moles of helium, 8 moles of helium, along with 1 mole of iron, which was of air, which was already there. Yes or no?
Yes sir.
The question at hand is you have to find the ratio of final pressure and initial pressure. So if the pressure here was P1, and now in this radioactive decay, this again being a system of rigid walls, nothing is escaping, the gaseous content from 1 mole has now become 9 moles. So the corresponding pressure P1 versus the corresponding pressure P2, I would certainly assume P2 by P1 would be number of moles N2 by N1, which is gaseous, and this has to be 8 plus 1 by 1. How many of you got this right? How many of you got this right? 9 का आंसर 9 है. 9 का आंसर 9 है. How many of you got it right? Please come up with your name. So I think this was within reach. I was expecting more of you to have solved it of your own. Nevertheless, we'll want to move to question 10. Yet again, you have a doubt here, you can ask me, you know, before going into solving the question, this was a more fundamental learning. That if you have a radioactive series given, you should be able to find the number of alpha and beta rays emitted. You know, I think I have been able to convey that alpha and beta both would affect atomic number. What would affect only atomic mass is only alpha. So, you know, you initially go by the difference of the atomic mass. And in this case, 32 by 4, 8 alpha emissions give me an understanding that to rise from 76 to 82, I would need 6 beta emissions. So 8 alpha, 6 beta is how, you know, I kind of began. And eventually 8 alpha, 8 moles of nuclei of helium, you know, eventually becoming the gaseous form along with 1 mole of air which is in the gaseous form. The final pressure versus initial pressure will be a ratio 9:1 only. But चलो हाँ ना बोलो.
ये प्रेशर वाला जो आप लास्ट में किए वो वाला पार्ट समझ नहीं आया.
You could be a little louder.
वो जब लास्ट में प्रेशर वाला निकाले वो समझ में नहीं आया. मतलब अल्फा बीटा जो निकाले वो तो ठीक है, उसके बाद
देख भाई
जब
ये भी सॉलिड है, ये भी सॉलिड है, ठीक है. एक बहुत कॉमन क्वेश्चन आता है कि हर रेडियोएक्टिव माइन में हीलियम गैस मिलता है. I somehow expect you to know it before class 11. हर radioactive mine में you have helium gas found because you know that alpha rays are nothing but helium nuclei, and helium nuclei will get electron from the atmosphere, will become helium gas. Now, when you know that uranium to lead 1 mole is about losing 8 alpha or 8 helium, you know 1 mole of this when converted to 1 mole of this would give you 8 moles of helium. Yes or no?
हाँ.
Helium is a gaseous compound. Sorry, element. Helium is a gaseous element. You have only 1 mole of a gas here. Rigid walls mean the volume will not expand. So pressure will be proportional to number of gaseous molecules. Initially, number of gas was 1 mole. Assuming there is no temperature change at the same temperature, now you have 9 moles. 1 mole of the air which was there and 8 moles of helium in the gaseous form. So the gaseous number of moles from 1 mole has now become now 9 moles.
ठीक है सर, समझ गया.
Is it valid?
हाँ सर.
Sounds good. I'm happy I'm able to recall and identify your voice as well. Question 10 is again about a very basic fact that out of the 18 groups in the periodic table with atomic number, you should be able to find an element belongs to which group, and I would want to hear it from more of you. A particular radioactive change is again given with copper with proton, copper 2963. Copper 2963 with a proton, hey, is giving me 6 neutron and 4 alpha particle, 1 alpha particle, I'm sorry, only 1 alpha particle, and 2 proton as well, and X. So basically, I have to find this A, to find X belongs to which group. The question is X belongs to which group in the periodic table. I think that's the question all about. And somebody will want to tell me the right answer before I give you the right answer. I think it's within reach. Please go ahead, tell me.
Read.
Sir, is it 8?
So read.
If 8 is the common answer, it has to be the right answer. Naturally, 29 plus 130. 29 plus 130, I'll want to add the left hand side is 30. Here I'll want to add 2 plus 2. And naturally A has to be 26. 26 I know is iron. 26 I know is iron. Hmm. 26 I know is iron. So this X has to be iron, and iron belongs to group E. It sounds good. Question 11. Are you all happy with this? Question 10. Are you all happy with question 10?
Yes, sir.
Question 11. Number of neutrons emitted. When again, again 11 is such a routine question. And this is where I tell you that even in JEE Advanced, the questions are, not that challenging from certain topics like nuclear chemistry. 92 to 35. Uranium 92 to 35 is disintegrating to xenon 54 142 plus strontium 3890. You have to find the number of neutrons which come out of this process. I think that's the question. Is that the question? Simple as a clerks. X is gonna be
So 3.
Sir, 3.
so you have questions as simple as this in the real JEE exam. So 2010 is again not something extremely old. And total number of alpha and beta particles emitted in uranium 92-238 to uranium 82-214 is something which all of you would want to do with 100% precision right now. Please go ahead. Yes, please. I hope I've written the atomic and mass numbers properly.
So 6 alpha, 2 beta.
6 alpha 2 beta comes
Sir, 6
from
alpha 2 beta.
6 and 2 is the common answer.
Yes, sir.
And I think this is how you go about it. 238 minus 214 is how you begin. Because you know this will be affected by alpha emission only. And if it's like 24 by 4, you confirm it's 6 alpha. And now it's 6 alpha gone. You could very safely remove 12 hydrogen from here. And 92 minus 12 I know is mercury 80. Mercury 80 becoming lead 82 is naturally about losing 2 beta. There is a popular rule called Fajan-Soddy rule. There is a popular rule called Fajan-Soddy rule. You know, around this time, I think I can talk about it. Around this time, I can talk about it. What is Fajan-Soddy rule? एक और साइंटिस्ट का नाम मेरे को भी याद नहीं आ रहा है. याद आ रहा है कि तुम लोग को फजान सॉडी और एक और जेंटलमैन था. The rule is, if suppose you have X with atomic number A and mass number M, losing an alpha particle, it will become Y, which will be like A minus 2, M minus 4, which again, if loses a beta, would become a Z, which will be like A minus 2 will become A plus 1. Are you all there with me? And if it loses another beta, are you all there with me? बच्चे लोग हाँ ना बोलो.
Yes, sir.
Yes, sir.
So every alpha, and it will move to left 2 units in periodic table naturally because the atomic number will decrease by 2, and every beta it will move to right 1 unit in periodic table. Naturally, I'm talking about the graph. Move to 2 units left or right and then the vertical columns. Also, 1 alpha and then 2 beta emission would give you an isotope. ये बच्चा वाला बात है. You understand X and X prime are isotopes. Yes or no? बच्चों लोग हाँ ना बोलो.
सर वहाँ पे आप A -1 होगा ना, Z M -4 Z A -2.
Sorry about this. Sorry about this. But I think I'm being understood. I can make mistakes of this kind, and I'm always happy with you correcting me. Alpha and 2 beta emission will give you an isotope like you have X and X prime, and the beta emission would always give you an isobar like you have with Y, Z, and X prime. But चलो हाँ ना बोलो. फजान सोडी and एक और आदमी था
Russell.
नाम याद.
Yes, sir.
Russell.
Yes, please.
Sir, Russell.
रसेल था क्या?
हाँ सर, अभी देखा गूगल पे.
ओ ये एंड्रू रसेल वाला है क्या?
सर एंड्रे.
एंड्रे रसेल वाला. वो एंड्रू में क्यों बोलो? आंद्रे रसेल वाला. ये क्या? आगे बढ़ते हैं. क्वेश्चन 13 देख लें क्या बच्चे लोग? 13 देख लें 13। मैं 13 लास्ट कराऊंगा बिकॉज जो 14 के बाद 13 के बाद जो क्वेश्चन है ना वो मैं कल भी नहीं कराया था अराउंड दिस समय तक, इट वॉज प्रीटी लेट। तो आज मैं 13 करा देता हूँ, बाकी मैं क्लास में कल डिस्कस कर दूंगा या मंडे डिस्कस कर दूंगा, जैसे जिसका जो बैच होगा। सैटरडे डिस्कस कर दूंगा फुल बगान बैच में, संडे डिस्कस कर दूंगा फुल बगान बैच में, मंडे डिस्कस कर दूंगा हावड़ा बैच में। 13 खत्म करते हैं। 13 एडवांस 2022 2020 का क्वेश्चन है, कोई किया है क्या? एडवांस 2020 का क्वेश्चन है। क्वेश्चन 13, uranium 92 to 38 becomes lead 82 206. Uranium 92 to 38 becomes lead 82 206. ये नेचुरल सीरीज है। कोई मेरे को क्लास में मिलके बताना तो कि इसको 4n+2 सीरीज क्यों बोलते हैं? Somebody will want to tell me in the class this is the natural series and it's called radioactive series which is a 4n+2 series. इसमें हम लोग निकाल लिए ना कि यहाँ पर 8 अल्फा और 6 बीटा निकलता है, मेरे को तो याद हो गया है। देखिए ठीक कर रहा हूँ क्या? 32/4 8 और 8 दूनी 16 निकलेगा 76 76 6 82। ठीक है, ये मेरे को लग रहा है मेरे को आता है ना। A rock initially contains uranium which is 68 into 10 to the power minus 6 gram. So it says about uranium at time t is equal to 0 having 68 into 10 to the power minus 6 gram of uranium. And if the number of alpha particles emitted during its radioactive decay to lead in 3 half-life is there in 10 to the power 18, what is the value of Z? If number of alpha particles emitted in 3t half, now this 3t half is important. This 3t half is when, you know, this U naught would have become U naught by 2, then U naught by 4, and U naught by 8. So the number of moles left would be 1/8 and number of moles decayed would have been 7/8. If the number of alpha particles emitted in 3t half is 0 into 10 to the power 18, find Z and get a number. I have it recalled because I solved it very recently. कल के बैच में मैं सॉल्व किया तो मेरे को इसका आंसर पता है. Any one of you could solve it? Any one of you who got it solved? You have an answer and the explanation. The question is as simple as it sounds. You know, this is uranium dating, which is used to find, the age of a rock or, you know, landscape, which is kind of a few million years old. But here they're not talking about the age, they're talking about the fact that if this is the initial amount of uranium you begin with, and in 3t half, if this is the amount of alpha particles which have come out, what is that? A nice way of asking a numerical value question. Anyone who has solved it? Else will solve it? Now, allow me to write number of moles of uranium at time t is equal to 0 to be 68 into 10 to the power minus 6 upon 238. I think nobody will complain with this. Mass upon molar mass is number of moles. Yes or no? अरे हाँ ना बोलते हो यार.
हाँ सर.
Number of moles decayed is 7/8 because 1/8 is the amount left in 3 halves. This is the number of moles decayed.
Yes.
So the number of alpha particles, now I want the count. Now with 1 mole, if you have 8 moles of alpha particles coming out, the number of alpha particles would be like 7 by 8 into 68 into 10 to the power minus 6 upon 238 into the Avogadro number. Yes or no?
Yes, sir.
Which I believe will be like 7 by 8 into 68 into 10 to the power minus 6 upon 238 into 6 into 10 to the power 23. I was solving it yesterday and it was such a pleasant surprise. I hope you all can hear me loud and clear. Please respond with a yes or no.
Yes, sir.
Now this could very well be a multiple of, is it a multiple of, what is the multiple, I could get a multiple of 17 or something.
सर
So
7 से जाएगा
7.
34 बन जाएगा.
ये किससे मल्टीप्लाई हो रहा है 7 से
So 7 से
से
34 हो जाएगा, 34 और 68 में कट जाएगा.
7 से ये कैंसिल हो जाएगा 34 and 68 will become 2 and और 4 6 by 4 is ये 1.2 आंसर आया था लेकिन करें एक गड़बड़ कर दिया हूं यहाँ पे इंटू 8 नहीं किया हूं ना इंटू 8 भी तो होगा ना
हाँ सर.
इंटू 8 भी तो होगा ना 1 मोल से 8 मोल्स आता है तो इंटू 8 भी होगा ना if this is the number of moles decayed this into 8 and will be number of particles of alpha particles which will be emitted. So I want to write 7 by 8 into 68 into 10 to the power minus 6 into 6 into 10 to the power 23 into 8 upon 238 if I'm doing it all right. Somebody told me it's 7 into 3, 21 and 34. So this will be like 2 times of this. 8 and 8 will get cancelled. This will be like 12 into 10 to the power
17.
minus 17. I kind of remember the answer. So, I could kind of.
So 17 होगा.
यहाँ पर 1.2 आएगा आंसर फाइनली है ना
हाँ सर 1.2 आ रहा.
So don't commit a mistake which I did. I mean I can obviously correct myself because I know the answer, but a small little mistake which I committed, but I think we are having no confusion right now. You begin with mass upon atomic mass as the number of moles of nuclei, and 7/8 of this has got decayed because 1/8 will be left in CT half. So this is the amount decayed, and with the amount decayed into 8 and 8, I'll get the number of particles of alpha rays which has come out. So this is where I wanted to kind of stop tonight. Thanks for joining. In the other batch also, I've done till this point only. So the rest of the questions I would do, parallelly with all of you. Stay happy, stay healthy. See you people in the classes in the weekend. Take care. Good night. Bye bye. God bless you all.
Thank you, sir. Bye, sir.
Bye.